All right, hi everyone. I think this is a record for me. We have a class of 16, and today, Friday the 27th, we have 10 people absent for athletic events and early dismissals. As such, what I'm doing here is 2 screencasts. The first one is for you to go over your homework, which was the everything problem set, okay? And rather than going over it in class and risk some of you who are not there, which is overwhelmingly more than half the class, missing something, we're going over homework right here, so no one misses anything. Okay, here's question number 1. And you'll see my formatting here is not perfect, but I think you should follow it perfectly fine. Question number 1 was right here. Okay, this is the continuous function f. The graph of f consists of 2 quarter circles. That was important because if this is a quarter circle, this is a quarter circle right here. That's a point of vertical tangency right there. Okay. All right, state any intervals over which f increases. F is increasing here. But at this point, f prime doesn't exist, it's a point of vertical tangency. Hence, look at my intervals of increase. See how -3 is not included? And remember I said to you before, intervals of increase and decrease are inclusive except on, under 2 conditions. If f doesn't exist at one of the endpoints, or if f is not differentiable at one of the endpoints, which is the case here. Number 2, part B, the local linear approximation to f of x and x equals -1 over or under approximates f of x justified clearly. Nowhere in part B were you asked to actually find the local linear approximation. You're just asked to say whether the local linear approximation would under or over approximate. Here is the point when x equals -1, okay, and you'll see here that at that point the graph of f is clearly concave down. Because f is concave down, which is saying the same thing as f double of -1 is negative, the local linear approximation to f of x at x equals -1 would be an over approximation of f of x. Okay? Part C, find the average rate of change of f on the interval from -4 to 3. Let's see, what is that? Average rate of change of f on the interval from -4 to 3. You know that this means the same thing as the slope of the secant line, which is this line right here, from -4 to 3. Oh my goodness. What a horrible line that was. But anyway, we want the slope of that line. And here it is. Average rate of change of f of x over the interval of x from -4 to 3, f of 3 minus f of -4, or of course f of -4 minus 3, all over 3 minus -4. We get -3 minus -1 over 7, End of the answer is -2/7. Why is the mean value theorem not contradicted? The mean value theorem is not contradicted because over the entire interval, f of x is not differentiable at all values. So right there is a corner point. In other words, if I were to ask you if you can even visually look at this, there is no place on this curve, on f of x, where there is a tangent line that would be parallel to the secant line. That doesn't mean the MVT is contradicted. The MVT is not contradicted here because the conditions of the MVT are not met, namely the condition of differentiability over the entire interval of x. Number 2, look at the green. Look at the green. Look at the green to the right. Okay. This is one that there were parts of this question on a prior test, I know that, but not all of them. Let f be the function given by this. For all values of x bigger than 0, that should make sense to us because the argument of the log could never be negative or 0. The derivative of f is given by here. A, write an equation of the line tangent to the graph of f at x equals e squared. Here is me finding the point of tangency. Here's me finding the slope of the tangent line. Look at all this work that I'm showing very cleanly. Tangent line is right here. Find the x coordinate of the critical point of f. Determine whether this is a relative min or relative max. This is one that I know you had in the recent assessment. Here's f prime. There is a point of non-differentiability at x equals 0, but x equals 0 is not in the domain. The numerator here will equal 0 at x equals e. The numerator of the derivative. Here's me doing a first derivative sign analysis. Conclusion, right here. Relative max by first derivative test for extrema. Part C says the graph of f has exactly one point of inflection. Find this point. Me finding the deriv, cleaning, solving. Most people stop here and say, see, I found it. You haven't shown that that's an inflection point. You need to show that at this point, there is an inflection point. An inflection point means that at that point, the second derivative changes sign. Now you can say there's a point of inflection at x equals x squared. The limit as x approaches 0 from the right of ln x over x. Numerator approaches negative infinity. The denominator will approach 0 from the right. Regardless of what happens here, this limit would not exist. Good. Third question, number 3. Look at the blue. Look at the blue smushed right in here. Blast from the past. Here's the function f. Show that f is continuous at x equals 0. Look at that. So at x equals 0, look what happens here. I'm showing f of 0 is equal to 1. So I'm saying f of 0 exists. Limit as x approaches 0 from the right. Limit x approaches 0 from the left. These are both equal to 1. And since the limit exists at 1 and the function exists at 1, and these two things are equal to another, by the definition of continuity at a point, we can conclude that f of x is continuous at the point in question. B. Find f prime as a piecewise defined function. Here it is. Here's f prime. Derivative of each piece, derivative of each piece. This is a great question. Find the value, and this is, when I told you that there's an infinite variety of calculus questions, the reason why there's an infinite variety of calculus questions is because there is an infinite variety of calculus questions. There is infinite ways to ask questions that force you to say, do you remember what the math means before the calculus and during the calculus, right? When I say there are infinite ways to ask a calculus question, what I'm saying is there are infinite ways to ask questions about all the math that you've ever seen up until this point, right? This is saying find the value of x for which f prime equals -3. Well, f prime equals either 2 cos x or -4e to the -4x. So the question is that to solve for x when f prime will equal -3, either this y, 2 cos x, could equal -3, or -4e to the -4x equal -3, right? When I look at this left-hand side and I try and solve for x, at this point, when I divide by 2, or even earlier, if you can see that far ahead, I say that the cosine of something equals -3/2, or -1.5. There's no solution here, because you know that cos x fluctuates between -1 and +1, right? It'll never dip down to -1.5. On the other hand, -3 equals -4e to the -4x. Divide by -4. Oh, look at this. You have to rewrite an exponential equation rewritten logarithmically. ln of 3/4 equals -4 over x. Divide by x. Natural log of 3/4, all divided by -4. Nicely done. Purple. Landfill. Look at the purple. At the beginning of 2010, a landfill contained 1,400 tons of waste. The increasing function W models the total amount of solid waste stored in the landfill. Planners estimate that W will satisfy the equation involving derivatives, which is just all that this differential equation just means an equation that involves derivatives, for the next 20 years. W is measured in tons. T is measured in years. I just made a note to myself that I'm dealing here not with y and x, but W and T. And W is a function of T. T's in years, W's in tons. I also made a mental note that if W is the tons at a certain year function, then the units of W prime of T, or dW by T, would be in tons per year. Okay? Just little mental notes for me to kind of make sense of what the information is. I have to find a line tangent to the W graph, which we are not given, by the way. A line tangent to the W function at time t equals 0. Well, at time t equals 0, the tonnage of waste is 1,400. We were told that. So that's the point of tangency. The question is, what is the slope of the line tangent? Well, dW by dt at that point of tangency, right here. 44 is the slope. So the local linear approximation is right here. Y minus 1,400 equals 44 times x minus 0. And then here's where I was trying to be very impressive. I solved this equation for y, and I had y equals 44x plus 1,400. But then I said, you know what? I'm just going to make sure that I'm really being thorough. The independent variable with my w function was t. So I'm saying that this local linear approximation approximates the actual amount of ton function, right? Then I use that local linear approximation to approximate how many tons of waste will be in the bin, landfill, at 3 months. Boom, 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 boom. Use the second derivative of W. The second derivative is 1/25th dW by dt. Okay? Reason why? The second derivative here is asking you to take the derivative with respect to time of dW by dt is 1/25th W minus 300, right? Is that right? Yeah. Okay. And maybe you're someone who likes to see this written out. D by dt of 1/25th W minus 12, right? D by dt of 1/25th W becomes 1/25th, dW by dt, chain rule, right? D by dt of negative 12 is a constant. But dW by dt, it's 1/25th times dW by dt. So here is 1/25th times dW by dt, right? And then W double at 1/4, I said it's going to be negative, but I was wrong. I'm not looking, I just caught my mistake. Goodness gracious. So good to go over it. Boop. Oh. Okay. Now I want W prime, or dW, W prime of t equals, oh, right here, duh, it equals that, okay? But at t equals 0, comma, W prime of t equals 1/25th times 1/25th times, what's W? Oh, look at this. At t equals 0, what is W at t equals 0? 1400 minus 300. You see what I did there, everyone? I had plugged in t equals 1/4 into W, but no, silly. At t equals 0 is when I want to figure out the sign of W double prime, but at t equals 0, W double prime is not in terms of t, it's in terms of W. So I had to figure out what W is at t equals 0 and then input it in. Anyway, at t equals 0, W double is positive, which means the W function is concave up. Therefore, the local linear approximation is an, what, everyone? Is an under approximation. Okay? There is the full homework going over of the everything problem set.